Hi, everyone. It's my second opportunity to present to this audience. Back when I was CTO at NASA, we had just launched a project called OpenStack. My colleague Josh McKenty, who is now at Pivotal, worked with me on that initiative. And we have a distinguished panel today that will be talking to you about building and operating complex applications in cloud environments, and in particular in hybrid cloud environments. And we want to each talk about this with a framework that I think will be something that you can follow. So what I thought we would do is work our way up the stack. Ulf runs the cloud platform in the cloud at HP. And HP sells a lot of servers and infrastructure and network components. So we'll start by talking about the foundation of the cloud infrastructure. We'll move up the stack and we'll talk about infrastructure services. I'll talk a little bit about OpenStack. We'll move yet again up the stack and talk about platform services and the foundation of really running highly agile applications. Josh will talk about how Pivotal helps you do that, and then we'll move up the stack from there and we'll talk about an actual software application, SAP HANA, and then we'll move up from there and talk about how this whole stack and through open standard interfaces we can actually move applications between different private and public cloud environments. But before we get there, I just want to say one thing. When we think about these applications, how many of you, by a show of hands, run a very strategic, large application that does not integrate with the existing infrastructure in your enterprise? Zero. So one of the things that I want to really make sure we all touch on is how important it is to look at cloud as not a destination, but as a journey. And over the next 10 years, you will have trillions of dollars combined of infrastructure, people, processes, procedures, networks, and applications and data that you've invested in. And the key to taking advantage of platforms like ERS and Werner and these public cloud platforms, which are truly amazing, if you're starting a new company, there's no other place to go, is that destination. It's how you bring these existing data centers, existing applications, existing investments you've made into this area. So with that, I'm going to turn it over to Ulf to talk a little bit about the foundation of cloud at HP.
So I'll tell you about the geographic and the network layout, a little bit of how the data center, things are laid out within the data center, and then what's happening within the rack. It's very straightforward. So if you think of a production environment in North America, say there is a data center in East and West, within each one of them you have 3 availability zones, or at least that's how it's presented to the user. And you synchronize critical data between the different regions, such as user data, some security, some billing and usage data. Within a data center, you have each one of these availability zones are built with quite independently, literally walls in between, so that in case one gets flooded, the next one doesn't. Whether it's chillers, whether it's power circuits, these are all completely separate. Otherwise, it doesn't really make sense to call it an availability zone if they're interdependencies. Each one of them is equipped with a network layer to aggregate traffic between the AZs, but also to the outside. And then we made the choice that it is enough to have 2 access points externally per region. So we cross-connect all the AZs with those 2 access points, and we equip each one of the access points with all the intrusion detection and DOS mitigation and other security hardware and applications. If we then zoom into a given data center, and you see in the schematic there are these 3 AZs, and again they're literally in different buildings, literally there are walls and security people in between. It's a very straightforward design. There are basically 4 types of racks. There are those that are used for the network infrastructure or some of the core infrastructure, whether it's logging servers or or monitoring or deployment control infrastructure. And then you have compute, object store, and block storage. And so the compute racks are interchangeable. You have one SKU to order from the factory, and it gets brought in, is pre-configured, you can drop it in, and it just plugs into and then becomes part of the capacity in the cloud. Same with the other, with object storage and block storage. We're actually in the current generation of hardware bringing that down to just 2. So we're reusing compute nodes also for the core infrastructure. And with SDN, there's some really interesting opportunities. And then if you look at the individual racks, what the schematic wants to express is that we mix control plane and data plane in the same rack, so that you can take advantage of redundancy across individual racks in case you have failures at the Tor switch level or in terms of power. So in the middle, the little gray zones are redundant Tor switches, top of rack switches that are not on top, and then the ILO network. That's the simple view of what this looks like at the bottom.
That cloud that you were just looking at is actually powered by OpenStack. And HP was one of the first partners that we lined up out of NASA to really give OpenStack a tremendous investment in engineering resources and, of course, to put it into production in the HP cloud environment. So back when Josh and I were at NASA working on this thing, OpenStack was just 2 projects. So how many of you are familiar with OpenStack and the architecture? We talked a little bit about it today. So I'll cruise through this. Very shortly thereafter, a lot of work was invested to expand the scope of OpenStack. And the project kind of evolved to provide an abstraction on top of the core things you need in order to treat infrastructure as a set of services. So as we kind of move forward, the yellow shows the progression of OpenStack as projects. In 2013, we added Cinder, which is an abstraction on top of block storage devices. We have Swift, which is an abstraction of object storage. So you can compare these directly to Amazon EC2 and EBS and S3. Kind of moving forward, we added a project which was briefly called Quantum and now called Neutron, which provides you a set of APIs to express networks. So now at the bottom of this stack, we have computing as a service, storage as a service, and networking as a service, so flipping, storing, and moving bits. Then above the stack, we have Swift Glance as services, a security framework called Keystone Heat, which is an orchestration platform to instantiate infrastructure, Ceilometer, which is a telemetry platform to measure how the cloud's working, and of course, command line and tools. Moving on into 2015, we added an SDK. We added schedulers, secret management. So this kind of gets to the point that was made earlier by Urs. This is a huge project. We will be having, I believe, our 12th big summit in Vancouver, where we'll have probably nearly 10,000 people in one city. And we do this every 6 months, where we design this thing and we bring in people. Each one of these projects literally has a team of people that is elected and works closely together to design the initiative. And they're sponsored and supported by about 300 or 400 companies today. So when you look at the velocity of this open source project, we have an active contributor base of about 600 people in a rolling 30-day period. So these are actually developers that are making code changes that are committed to the trunk of OpenStack. So really the question has been, how do we manage this thing, because it's been growing so fast? So with that, I'm going to turn it back over to Josh to talk about what you can do when you turn all of your infrastructure into a set of services.
Thanks, Chris. So it's somewhat ironic to me that when Chris recruited me into NASA, the goal was to build a platform as a service, and we got sidetracked into doing OpenStack because there wasn't anything that would work at that layer. But I have finally made it back to platform as a service in the last couple of years. And just looking at the history of the last 10 years, this sort of interesting decade that Urs was mentioning, 10 years ago we invented configuration management with Puppet. And in the intervening decade, we launched the App Store. We had the launch of Hadoop and the entire big data ecosystem. We had the launch of Facebook, and Netflix stopped mailing DVDs and started streaming video. So most of the problems that make IT difficult did not exist when we started doing traditional configuration management. So if you look at CAPS, in terms of Chef, Ansible, Puppet, and Salt, it's not well fit for solving distributed systems problems, which is really what most applications look like today. So I work on Cloud Foundry at Pivotal, but whether you're talking about Cloud Foundry or you're talking about some other PaaS or platform solution, the main criteria for a platform as a service is not to be a scripting language to launch VMs or containers, but to actually be a state machine that deals with owning the state of your infrastructure that supports that application. So we like to think of VMs and containers as both being useful primitives, along with block storage and object storage and network connectivity. And all of those infrastructure primitives need to be orchestrated, not just in the simple sort of day one deploy problem, which everybody has a demo. I don't know if you've heard of Doku. It's a 600-line bash script that clones Heroku to show that you can actually write a PaaS in 600 lines of bash. It only does a day one deploy. So when you go to deploy and upgrade, you essentially just start over. So looking at platform as a service as being really almost a narrow AI, artificial intelligence that owns the feedback loop of what the existing system state is, what the desired system state is, and the set of transformations required to get from one to the other, not at a point in time, but real time, continuously on an ongoing basis. And I think that's a useful framework to think about platform and how it consumes IaaS, and it's not an either or. This is not a versus. So I spend most of my time now talking to folks who run OpenStack who are now ready to put PaaS on top. And I think this is how we frame how they're complementary.
So I work on the infrastructure and the advanced engineering for infrastructure. So SAP has multiple cloud platforms with SuccessFactors and Ariba. We just purchased Concur. We have a multitude of cloud stacks that we operate and various development environments and platforms just internal for our cloud offerings. So we are on OpenStack and an OpenStack path and working with HP and multiple people to get that, and then so we can focus on deploying the SAP landscapes on top of that. And then we are a board member on with Pivotal on the Cloud Foundry, so we're expanding our Java stack and our ABAP stack into the Cloud Foundry, so we're moving in that direction. The topic was requirements or the hybrid cloud. So I kind of put down Clark's view of the world on what I saw and hear from customers on their requirements. One of the things about SAP HANA is it's an in-memory database. So it's in-memory first, persistent storage second, which creates a whole bunch of requirements on the infrastructure that doesn't fit the typical public cloud scale-out sort of nodes. So my team, we design purpose-built application-specific infrastructure stacks to make HANA the best it can be. And then we evolve that over time and introduce it into our hybrid cloud, which we call HANA Enterprise Cloud. The idea is to take a customer's landscape that's a traditional SAP or client server or brand new applications that are based on HANA, to assess that, transform it to a cloud, then operate it in a managed service on behalf of the customer in a hybrid cloud. So we also want to address all the engineering challenges on how that evolves over time and how we orchestrate that. So we view that there's a place in the compute hierarchy for all of these clouds. And simply our goal is to put our products in front of the customers in the environment they want to consume it. So we have offerings on AWS, we're working with Azure, we're working with Google, the entire ecosystem. So one of the challenges I just wanted to point out, so the next slide, is there is a major transformation happening. So if you look at memory pricing that we talked about going down, the explosion in interconnect capability, flash happening on the scene, and now all of a sudden, with the new advanced interconnects, you're going to have an explosion of bandwidth available to an application. So there's a big transition happening on how you apply flash, how you apply new memory technologies, non-volatile memory technologies, and create a persistency layer that is very high bandwidth and lightning fast. So the next slide just points out when Hasso Plattner, our founder and chairman of the board, came up with the HANA concept, it was from the point of view of how would that change data handling if you thought about zero latency or near zero latency. So what can you do to combine the transaction stream and the analytics stream and how could you give enterprise-level SLAs in a cloud sort of environment. So that's really the challenge that we're dealing with. It's how to put as much as we can of the active data in memory and to shorten the gap between the long tail latency items. And that's kind of what we focus on.
VMware is, as you know, the leader in the CPU virtualization. And of course, now we are extending this into the hybrid cloud, as we call it. And we actually made a partnership with Google very recently because we think that the scale that Google has is very important, and that's what can benefit customers that are looking for economies of scales in the cloud. But hybrid cloud is not just about the pure cost of infrastructure, as you can guess. A hybrid cloud means essentially being able to seamlessly move workloads from your on-premises to your off-premises, and maybe move them back again if needed. And essentially, as you realize, most enterprise applications, they have specific requirements of which cost is only one of the parts. You have SLAs, you have compliance, you have security, and all those things are not exactly easy to manage or handle when you just need to run things in the cloud. Sometimes tools are not there, sometimes it is just too complicated. In our case, of course, we have the luxury of having a huge installed base that is already using the VMware stack in-house. So what we did was to take this stack and essentially build a cloud version of it. And then, of course, we let customers move to the cloud without changing anything, without re-engineering, without thinking of different APIs or different models. Of course, this is the initial step. We understand that the market is evolving, and of course, public cloud will become bigger and bigger in terms of IT spending in the coming years. And in fact, we have partnerships with the Docker and with Kubernetes, and we're essentially trying to help customers do whatever they want, either on-prem or in the cloud. And we think that this is something that any cloud provider has to deal with in the coming years, because there is a limit to the amount of new applications that are already built and designed, stateless, distributed, which is what most of the AWS workloads are made of. But there are situations where you have legacy software and you have to somehow transition that software into the cloud. How can you do that without re-engineering everything? Because sometimes it's production systems, sometimes you can't even afford for years to change anything in that system, or it will simply be too expensive, which will just offset the savings that you made by moving to the cloud. So this is what VMware is doing. And we also announced very recently a version of OpenStack, which of course allows customers to run an OpenStack distribution maintained by VMware in partnership with the OpenStack Foundation. We think that hybrid cloud is going to be one of the hottest topics in the coming years. We think that every CIO and CTO in large companies will have to deal with a hybrid situation. And the key components will be management. How do you manage different diverse environments? It will be compliance. How do you keep compliance across different environments, possibly even across different clouds? And then, of course, security. And as much as containers are very promising in terms of enabling apps to be portable, of course, security around containers is still nascent. It's still very early days. And therefore, you need, in most cases, to have some supporting help